Okay, so this is the Total Station Lab. Total stations are expensive pieces of equipment, and they're actually used in industry. Theodolites, auto levels, and chaining. They used to be. New technologies come along, others become obsolete. They're still used for specific purposes, but in reality, you will be working a lot in industry with total stations or GPS units, which we don't have one, but we will talk about one in class. So this is our total station. We have two, and this is actually on loan from City of Waco because they are very expensive. So please be very careful with it and just follow the same care indications we talked about with the theodolite in the previous lab about unboxing it and putting it back in, and how to carry it using the top part, which is meant as a handle, and not touching anything else as you're carrying it. It has a tri-brack at the bottom, and we're going to mount it to the tripod in the same way as we did the theodolite, very carefully aligning the knobs with the shape of the tripod and locking it in place. Also, there is a nail on the ground, and of course being totally on top of the nail is key. So there's a few things that are different about the total station. It requires even more precise of a setting of a leveling, than the theodolite, and it will not, as opposed to the theodolite, which will still work even if you're not perfectly level, this one won't even take any measurements. Okay, so let's go ahead and level it. You know how to do that, and we start, just as a reminder, once we are happy with our tripod setting. This seems to be an okay height for this. I'm gonna go look over here for the bullseye level indicator, and because the bubble is right over here, I am going to use the opposite knob. Oh, and I also turned all the knobs all the way down, or let me make sure. Yeah, I had messed with it a little bit. Oh, I'm going the wrong way. So all the way down, yes. That's a good way to start, go all the way down with all three, okay? Yeah, the bubble is still over there, so I can come back here, and I'm gonna use these two knobs to help it move towards the middle. It is moving. Oh, there it goes. It starts heading inwards. I stop for a second to let it kind of settle. Looks really, really good. Something else to think about, and this is for when you're in the field, is these things run on rechargeable batteries. So as opposed to the other one, the theodolite, this one needs to be recharged, not just battery swap. So make sure you've done that before you head out. I'm turning it on. So we've turned it on. It's kind of hard to see, there's a little bit of glare, but you will see that it says wide tilt over. So there's no readings for the vertical or horizontal anything, even though our level shows that it is, right in the middle. Maybe a little bit off, but not too bad. It still says wide tilt over. Now you will see that for a second it's fine, and then it goes back. That's because there's this other level indicator, and it is not centered, so it's going to give us grief. So same as last time, we're going to do this 3 times by aligning. First, this is locked, well, it was locked. You have to unlock it, let it move this way, align the bubble in between 2 of the knobs, and let it settle. Right now it's moving a little bit that way, and remember, these are kind of fine tuning the level, so I'm gonna move it very little and wait for it to settle a little bit. Looks good. I'm gonna do it here, aligned with these 2. Let it settle. And when you're turning it, it immediately says tilt is over. Don't worry about it. It'll kind of go back to normal once the bubble has found its place. That looks good. And if you see, my movements are very, very small, because we're very close to being perfectly aligned right now. This one seems just a tiny bit off, like that's how much it needed to be moved. Yep, there's 2 lines, you want it centered, a little bit more, right around there. Okay, so now you want to be really, really careful, because anytime that you move it, you kind of have to start that process over. Which I did not show you one part, so we might have to do this again, which is actually checking that you're over the nail. I think I'm perfectly over the nail, but I don't actually know that, and with The theodolite, we had an optical plummet that you would look at here and see the bottom. This actually has a really cool feature. So over here in the menu, we have, if you go down, so this is menu, and these mean different things, and we'll kind of play with them a little bit. So I'm gonna go, hold on, down, this is, okay. So you see I did menu, F4, and then by going page down basically, and it gives me 3 options, F1, F2, and F3. F3 is called the laser plummet. So the laser plummet, we click, there, turn it on. Now this will run the battery real quick, so just use it. And you see that there's a little light that is blinking, and it is, it's right in the center of the nail. Now, ideally you would turn it on before you do the fine leveling, because you know, if you are off and you have to move something, then you will need to do everything else. Okay, so I'm gonna turn it off, F2. This needs like to be pushed. I just turned it off, so I can go back to the menu or escape. Okay, so now what's really cool, so far, we've done everything the same, a few minor differences, but here's the cool part. The reason that total stations are very expensive and at the same time very, very useful, so worth the money if you're a surveyor, is that you're actually going to use, instead of the range rod or a range pole, you're going to use a prism. Now well, it's on top of a range pole, and we'll bring it out here in a second, but instead of you having to take any measurements and having to write them down, this is going to basically shoot a laser over to this prism that is going to be at a specific distance, and if it's properly calibrated, it'll give you the distance with a lot of precision right away. So it's really wonderful, and what that allows is for you to be able to take multiple points once you've set it up, which is the hard lengthy part. Then you're going to be able to just go, you can get 100 points right now of an entire field. And if you have something called a what is it called?
Data collector.
Data collector. I was going to say data manager. No, that's the wrong thing. If you have a data collector, which we don't have, those points would be immediately saved in the data collector, which you would create a file that you can put in your computer, load it into Civil 3D. So when you're doing Civil 3D, those points have been pre-collected and you're using points that are already set in there, but you would be able to collect those, put them in the computer and do stuff with them. So it's very fast once you get it all set up. So now that we are perfectly set up, we need some information. So the proper way to, if you're going to take a bunch of points, you need to know where you are in the first place. So there's 3 pieces of information you need. Well, 4 really. You need, you're going to need what is called here NEZ, which stands for Northings, Eastings, and Z for the elevation point. So for the practical purposes of this lab, we're going to say that we are calling this particular point 0, 0 in Northings and Eastings. And that's actually not an incorrect practice. If you really just care about points relative to each other, it doesn't matter. If you're doing like a survey of actual land and you need to know exactly where it's positioned, of course you need that information. But for now we're going to say 0, 0, and we're going to say that the elevation at this point is, what did we use last time? 37, because apparently that's my number. Okay. So this is what we're going to do. Oh, and the fourth piece of information I told you about is the height of the instrument. So just because that point is 37 doesn't mean this point is. So we need to know how tall this is so that the prism knows, and then it does internal calculations. So the order of this doesn't really matter. Let's do the height of the instrument first. So I'm gonna take, and you can take any kind of tape measure. Make sure you know if it's an add tape or not. And you're gonna see that there is a mark right here. So try to find a place in the tripod that you're not gonna mess up the legs. Find that point. There's like a line, a dot, and another line. And you can have a second person hold it, or you can hold it yourself as long as it has some kind of pin or something so that you're not messing that up. And because right now we are doing this preliminarily, I'm not gonna have someone else hold it, plus there's no one else. But I'm gonna try to be precise here. And let's see, try to get it as close to the center. And it seems to me like this is 3 feet. Oh, and I have it in, is this the hundredths of? Yes, 3.51. But remember, this is an add tape, so it has an extra foot. So it's actually, since it goes 1 to 0 and then 0 to 3, this is actually 4.51. Okay? So remember that number, 4.51. I'm going to carefully put this away. All right. So now let's see how you are going to input that over here. All right, so we are going to input the height of the instrument as well as my NEZ points. So I'm going to go over to here. So first of all, I'm in menu, but I actually need to go to this menu, and these buttons need some escape. Let me try that again. There we go. Sometimes escape takes you places. Okay, so in here, if you go to the second page, it has INS HT, instrument height. Okay, so to put this number in, this has 4.93. That was from the last time. Input, and we said it was going to be 4. So if I want 4, I select that grouping, 4, and then here's the point, and then we said it was going to be 5.1, right? 5.1. Enter. Okay, we have that. Okay, so now we're going to input the NEZ points, and to do so you're going to go down here, and remember we just did instrument height. Now we're going to click here where it says OCC, and here we're going to input one at a time. You see N first with the little arrow, and we said 0, so I mean it was already 0, really I didn't have to do much, but you know, if you want to see everything, enter. Let's say E is already fine, 0. And Z was 12 the last time, but I'm going to input, and I said 37. Enter. And now that you can't see the NEZ points, but they're stored internally as well as the height of the instrument. So now we're going to measure. So we have, by the way, there's lots of other settings here that are important, and it really depends on what kind of information you need in the file that will be given to you or as you collect information. But just know that if you needed to change the height of the prism itself, it would be here where it says RHT. It's actually the reflector height, because that's what it's called. And we can click escape, and there's all other kinds of information, a lot of it pertaining to things that we just don't have. But at this point, what I'm going to do is I'm going to have my crewmate stand straight with their with the reflector at the next nail, and then I'm going to turn this direction. Make sure, just for good measure, that you do one of these, you know, plunging the scope, just to make sure any calibration issues are kind of worked out within itself. And all I need to do now is come to click escape. And you see, I told you sometimes it says X, Y, tilt over. That's because we were moving it. But all you're going to do is click measure, and you're going to hear this creaking sounds. You actually hear them right now. It's looking for it, even though it's not out here. And then it's going to give you the 3 measurements, NEZ, based on the information we gave it. And you, in your case, are going to write them down. Okay? So let's see that part. One more thing is that you can use a total station as you did the theodolite as well. So on one hand, NEZ coordinates are very useful for computer programs, not so useful if you're doing simple calculations by hand. You might be interested in actually figuring out angles and vertical distances as well, and you can do all of this with that without the need of a computer. So we're going to have you write NEZ points, but I also want to point out that if you come, if you want to look over here, 1 second. So remember menu, and then over here, escape. So you have 2 options of how this information looks. I can't seem to go back to there. So you can have NEZ, or you can have vertical and horizontal angles. You see, remember, like the theodolite? Let me leave it in peace. So now, if I want to use this, I can actually go here to angle and 0 set the angle. Let's say that I'm pointing towards my other nail with the range pole, someone standing on it. So horizontal angle 0 set, and you click yes. You can do that. Now you see immediately that it moved to 359, but that's because I touched it and it wasn't locked. You can do stuff too with the vertical. You see how it changes? There is a way to also set that up to be 0 and then measure horizontal distances, although that's not something that we use this very much for. But just know that you can do multiple things with a total station depending on the purpose of your survey. So this is called the reflector. You'll also hear it referred to as prism because of what's going on in here. Actually, you know, there's different parts to it, although we'll keep it simple and we're just gonna call it the prism or reflector. This bottom part is called the range pole. And we sometimes just use the range pole. You may have seen it in the theodolite video just to point at the nail. It has its own level bubble, and of course you want it in the middle. So someone should be holding this and trying to keep it level like that. You should be on top of the nail. And what's really cool is there's not much else to do except point your total station at this, and it is already designed to find this, and it'll take a measurement when it finds it. So it's really, really neat. So someone like me taking measurements, let's say I have a colleague doing this part, if I want to take multiple points instead of having to move the total station, I am just gonna go here and there's gonna be a measurement taken, and then I can go here, another measurement, here, another measurement. It's that quick, okay? As long as you have this as level as possible, there should be no issues. And that's really great. Now, here's something we haven't talked about. What if there is a point that you can't see, that if there's an obstacle in the way, okay? This is important. You're gonna have to do this in one of your labs. So if there is an obstacle, let's say that here's where we set up, and one of the points I need is right here. There's no way for the total station to spot that. So what you're going to do is you're gonna find some other point that the total station can find, and you are going to make sure you mark it, okay? We're gonna mark this point very carefully with a nail, and because sometimes you don't even have nails, you're just taking samplings basically. But in this case, we do need to mark it very carefully because we're gonna take note of its NEZ coordinates. What we're gonna have to do is now move the total station with the tripod, and yes, we're gonna have to level it again, and yes, we're gonna have to change the height of the instrument and the NEZ coordinates within it. But once we put these NEZ coordinates, then from here, I can move over here and take this measurement. Does that make sense? All that matters is that you know that point and the height of the instrument, and now you can take a bunch of other points. So it is not uncommon that you do have to move it a couple of times during your survey, but it's a lot fewer, is that correct? Anyway, it's fewer times for sure than what you would have had to do with a theodolite or an auto level, okay? So we're gonna now show you how quick and easy it is. So as you can see, here we have one of the crewmates holding the reflector at a specific point, and I am going to now move the total station to point in the general direction. Now what's really cool about this is I don't need to be very precise because this does all the precision for me. I am going to lock the horizontal and the vertical once I see it through the through this that it's going to give me a general idea of where I am. I'm going to click, if you could see right here, I'm going to go to the this menu with the NEZ, and I am going to click measure. So you want to be pointing, give me a little space so I can look through here. You want to try to see the and it's really funny, the prism head, because you're gonna sort of see yourself. It has mirrors, that's why it's called a reflector. Right there, if you can see yourself, it means you should be able to take a measurement. So we're in NEZ, and now we're gonna take a measurement. So with the reflector prism in view, we click here, measure, and it takes a little bit sometimes. And there we go. Just be patient. Now, you see the format here. Let's look. There is a way to change the format depending on what you want, but this is information you would write on your notebook or a data collector if you had one. Okay, so we're going to be given this information in different ways, and it depends on what you want. So you can have it in meters, you can have it in feet, or you can have it in feet with inches. So watch out, this is 23 and then 10.1 inches. So MFI, meters, feet, inches. Okay, and that's it for now. But again, depending on what you want, you can also come see here. That's the horizontal angle based on the 0 that we set originally. I wouldn't pay attention to the vertical right now because we did nothing to it earlier, but it depends on what you want out of your time using the total station. So the other thing that you could do is if you want to use this to do some of the measurements that we did in previous labs, such as just a straight up horizontal distance or a straight up angle based on a previous angle that we set as 0, which we did, you're going to come over here to angle. One more up. This one. Oh, yes, sorry. You're going to go to this one. And in this one, you're going to wait because here where it says SD, it's going to take the measurement of the distance. The angle's already there, but it is going to take the actual horizontal distance, and you can hear it. It's going to take a second. And we're just going to know the straight distance from this point to the reflector. And there we go. So based on the angle that we set previously, and by the way, there's also a way to reverse the direction. Remember RL? So you can do this. So that would have been 43 degrees, 19 minutes and 21 seconds from that place. And the horizontal distance was, oh, we have to take it again, of course, but it was 32 something. There, 32. And there, we can also change the presentation of it from meters to feet, to inches. And there we go. Okay. And, oh. And now what is cool, and the last thing is, as I mentioned, now the person with the reflector can move. You don't even need exact points. You can just actually move sampling, kind of making a grid. If I want to see what this terrain looks like, that person would just take the reflector and move, maybe in particular distances to the right, to the left, forward, backward, and you could have samplings of points of the entire field and be able to upload them to to Civil 3D, AutoCAD Civil 3D, and immediately get a good look at what the terrain looks like with slopes and everything else. It's actually incredibly useful, and it would be fairly quick. It would probably, after we got everything figured out, probably take another 30 minutes and you can do a pretty wide area.
Now, something else that we're going to have you do that we didn't actually mention in the field is to take a compass measurement. So you can usually find an app on your phone that can do that. So the first thing we do want to write down before we forget to write it down is going to be our initial azimuth. And that's what we need in order to do the closed traverse, which is going to be the corrections on the closed traverse, which will be what the next entire lab is about, is just doing corrections on these. So as we're going through here, we can go ahead, and it's relatively straightforward, is just documenting the northing, eastings, and z values that we got from the total station. So remember that we had decided that our initial northing and easting on A was going to be 0, and then I think we said 37 feet. So actually that's done. Now for finding B, C, and D, remember we actually could have gotten all of those from that single point, but I'm going to write down the values we got for B, which would be 23,845 if you're being consistent with the video, negative 22,485. Notice we're getting a whole new decimal point on these that we never got in the using the other methods that we've used so far. Woo! And then 37.185. So actually, if you were able to see all of these from one setup, you could theoretically fill out all of these or any others remaining. And if you're in the field and for some reason you can't see one of these points, remember that you'll need to set up this table. Like go ahead and get all the points that you can, but like say you can't see D, you would need to set up this table for like at C, and then you could put those values into the total station and then indicate where D is from C. But you should be able to get the NEZ directly from the total station. Then, of course, we are going to go ahead and do the angles and the lengths, and that's when you're going to have to move the total station from point to point. So if we were measuring our first angle from the video, then that was, I believe, 43 degrees, 19 minutes, and 21 seconds. And obviously, we're going to need to change that into decimal. whenever we do our, oh, you can't see that, whenever we do our closed traverse corrections. But again, this is why this is important to do. Then we got our length for AB, which was 32.760. So the theory is whenever we do our corrections on our closed traverse, we really should get similar to the same values for the northings and eastings that we got in the, because you can get the departures and latitudes, and then you can find the coordinates for them. But in essence, this is really all you're doing. So we're kind of taking a little bit of what we've done in all the different labs, and we're doing all of it with one machine, and then we're going to do the corrections on it in the future.